Welcome to this edition of Open-SCAD by DIY3DTech.com. In this episode, we're going to take a look at building this. How did we code this and what is it for? So long story short is I've ended up purchasing a Seagate 1 terabyte portable USB 3 hard drive, and one of the reasons I purchased the particular model is it has a nice aluminum case, which we'll see at the workbench a little bit later, and it matches my Mac Pro's aluminum case. Now, one of the things though, as I tossed this into my briefcase quite a bit with a bunch of other electronics, I didn't want the cover to get all scuffed up. So what I decided to do was to design a sleeve for this and print it out of clear TPU so you could still see the aluminum case, but yet it would be protected. And then also I decided up here to put some knockouts, so again you could pull the drive out easily, because without this, obviously, if you slid it in, it'd be very difficult to get it back out. So while not very complex in design, I did want to share a couple workflow design aspects of this, which turned out very interesting. So one of the things that I've done is, if a lot of you folks have, if you've been following this channel, is I typically center everything. So this I decided to take a little bit of divergence and use false instead of center. And with this, changed a few of the nuances, especially how we handle the translate. So we're going to start out with the code, and so in short, it's pretty much like I do all my codes. I've got the standardized template here. I've defined all my parameters up here under the parameters section. I do an execute of a module, so everything is designed in a module, and then I define the module here. Now, one of the things that I always do is, difference in union. So the concept here is I always assemble everything, i.e. the union, and then I take a difference of that combined union. Now, in this case, if we take a look at this, pop in a percent sign, the union is only going to be one object, and that's going to be the outer case here, as you see in gray over here. And what we do, long story short, is we take the base dimensions, for example, here is the width, and then we add wall thickness. Now, one of the things I want to point out is when you're doing it, you're going to need to add the wall thickness twice. Because obviously there's two sides, so there's two sides to depth, there's width, but we only have a single wall thickness on height because we don't have a top. It's a hole over here that sticks out, so we only have to add it once for the bottom. So kind of just one of those little simple tips to kind of keep in the back of your mind, because you might just say, oh, I'm just going to add the wall thickness to width and call it done. And then what's going to happen is you're only going to get half of your wall thickness. So just a little tidbit. The second thing that we do is we come down here and we now translate out all of our parts. Now, typically one of the things when I do a difference, I really don't union the parts together that I'm separating. So because at the end of the day, the difference is going to be the result of my union minus all the pieces that I'm taking apart. So you could reunion these. I shouldn't say reunion these. You could create a union and then subtract, union 1 from union 2. But I think it's just a bit of overhead. But anyways, kind of worth a workflow note. So what I wanted to do is talk a little bit about this. And so what we do here is in the center knockout. So let's go ahead and pop in a percent and repaginate this. And so you see the center here. Now, one of the things is with this is I've added +2 to the height because I wanted this to stand 2 millimeters proud. So I always have a clear hole popped up in here. And so as you can see, I've achieved that. Now, one of the things to kind of keep in mind is when you do your translate here, you're going to have to add in that wall thickness plus the difference, or not difference, but the additional 2. And so you see that here. So kind of keep that in mind as you're going through this. And this is all pretty straightforward. Now, where it gets a little bit more wanky, if you will, it took me a little bit of time to figure out, is the actual cylinder for the grip. So this was kind of interesting, and this is what I want to share. So let's take a look at how this is created a little bit more. And so what we did here is we simply created a cylinder with the grip radius and everything that we wanted. So nothing fancy here. However, notice that we did for the wall thickness, we had to add it back in. Now I went 4 to make it stand proud. So you notice that it always stand proud the width times 2 of the box. So I get the extra width out here, so I clearly am proud of both sides of the box, and it'll make a nice clean hole both in image and production. And it's parametric too, so no matter whatever you scale the box, it'll always be that much more. So just kind of like a little workflow tip. The other piece we do is we use the rotate command to flip it around by 90 degrees, so it cuts the what I would call the short end or depth of the box in this fashion. Because if we didn't, if we say we went this way and we looked at it, see how it orientates it, and that's obviously a problem. So we want to change that to 90 in the X and go back here, and it's nice. The other piece here, and this is sort of the whole thing of this. Again, this is a pretty simplistic build. Not a lot here, but I do want to share a couple different things. One is utilizing false versus true in the centering, and then how that affects your translate, because one of the things, the way I look at translate and rotate, is rotate affects the orientation of the object. And again, I'm kind of stating the obvious, but when you're thinking in three-dimensional space, and I'll probably do a video dedicated to this, is think of yourself in a room. So rotate determines your orientation in the room, and then whereas translate determines where you are located at inside the room. So this is where I kind of want to share a little bit of this workflow, because this workflow got kind of a little bit wanky here in figuring out some of these pieces. So kind of long story short, especially this piece right here, so wall thickness times 4, because remember we have sized the cylinder to be the wall, the size, the depth of the box or the center opening of the hard drive, plus the wall thickness, plus the wall thicknesses again. Obviously, you have 2 walls to do that. Now, one of the things is you have to subtract out one of the wall thicknesses because you're utilizing false. This is where it got a little bit wanky for me, because I'm so used to dealing with I should probably just highlight the one piece here. I'm so used to dealing with center where I split the difference. You don't split the difference in false, so I had to back off one of the wall thicknesses to maintain the center, because if I were to say remove this, and then let's go ahead, you see how this now moved off center. So no matter what I do, I cannot get that center unless I go back and remove that singular wall thickness, because I am offset from my origin because of the false. Whew. I hope that made sense. It took me, it took me a few minutes of thinking about that, again, because I'm so used to dealing with center. To accept that piece of logic. So anyways, that's one of the big pieces I wanted to share here and how the translate works. So the other piece with this that I really like is the flexibility of this. So you can use this not only for hard drives, you can use this for cards, you can make pencil cases with it. So say for example, we wanted to do something that was 80 by 80, and I'm actually thinking about doing this. So as you see, we create this nice box. Let me pop out this other percent and then just redo this. So you see it creates a nice little box for us that we can print out. Now, one of the things I'm going to experiment with is printing this in vase mode or spiral contour mode in Cura. And I'm going to print this in TPU. Now I'm going to go back to printing doing it in the standard size for the hard drive. So this is what we're going to print out. Sorry for bumping the mic there a little bit. Anyways, this is what we're going to print out. We're going to print it out in TPU. We're going to go to the DaVinci, and I'm going to use 250C for the filament temperature and 60 on the bed. So let's hop over it. Let's watch a quick time lapse of this printing, and we'll see you back at the bench, and we'll talk about the results.
Okay, welcome back to Open-SCAD. So we took a look at the code inside the computer, and here's the actual hard disk that we modeled the design upon. And you saw the time lapse, and here's the result of the time lapse. Now, unfortunately, in printing it, we had some deformities here. And I think part of the problem is the temperature at which I printed this at, because I have been printing TPU on the Wanhao at about 250 C, and I did it on the DaVinci, and the DaVinci does a nice job at it, but I think I'm running it a little bit too hot, and it extruded improperly, because one of the problems, I don't know if you can see in there, but it's kind of globbed in there. But again, the model seems to work very well, and again, you know, this slides in, and I can slide it in about until I get to this globular down here, and that's sort of the problem. So I'm not going to kind of force it all the way in down there. So I have given a shot at reprinting it in a couple different ways. And for example, in this version, I tried changing the wall thickness. You know, this one failed. Again, I tried. Now, one of the things to mention is when I printed this, both of these two. This is a 1.5 millimeter wall thickness. This is 1 millimeter wall thickness. The 1.5 did far better than the 1. And then what, and I think if you're going to do this, now this is more of an opinion, is I would probably print at a multiple of the nozzle diameter. So the nozzle diameter is 0.4 millimeters. And so, you know, this one, I think, came out at an odd number, and I think 0.5 came out better. I think even printing at like a 1.2 or 0.8 would probably be better, but I think maybe 1.2 would be about the best, because this is 1.5, and this came out pretty good other than this blob. So I did try reprinting with infill rather than the equivalent of ace mode in Cura, and this is what I got. So not good. I did jump back up from this one to this one, which is 1.5. It fits beautifully, comes out nice, but the problem is now I'm having problems with the extruder pushing the TPU. So, which I should probably mention up front, I'm using TPU to print this because it's, as you can see, it's flexible, very rugged stuff. Excuse me. And then it's clear TPU, so you can kind of see through, because one of the things I did is I wanted to kind of keep the aesthetics of the hard drive itself, because it matches the Mac Pro case. And then the idea is I wanted to have, as we talked about in the other video, is I wanted to be able to have the area here where my fingers could grip to pull out the hard drive. So anyways, hopefully you found this build interesting. Hey, if you did, give it a thumbs up, subscribe to the channel. A lot more stuff on Open-SCAD coming in the future, so stay tuned. Also, hit me up in the comments below if you're interested in seeing something particular, or you have specific questions about Open-SCAD, especially as it applies to your workflow or something like that. Hit me up below. Happy to discuss it with you. Cheers.